Welcome to Science View. I'm your navigator, Rena Yamada. Science View covers the latest advances in Japanese science and technology. This week's Science Watcher is Dr. Eiji Mizushima of Tokiwa University.
Hello, I'm glad to be here with you today.
Here's today's lineup. Today's The Leading Edge is new wind turbine technologies. And on J Innovators, Michelle?
Today I will show you some amazing new technology that is used to print high-resolution images on curved surfaces.
But first, today's Science News Watch. What caught your attention, Dr. Mizushima?
I focus on news about the Japanese gecko. It has long been considered native to Japan, but it may actually be an introduced species. German physician Philip Siebold came to Japan in early 19th century and obtained a specimen of this gecko. Siebold reported it as a new species, and ever since it has been considered native to Japan. But now, Professor Hidetoshi Ota of the University of Hyogo and his colleagues have a new idea. They compared the genome of Japanese geckos in China with those in Japan and found them to be almost identical. In addition, there is no mention of Japanese geckos in Japanese literature before the 12th century. Professor Ota thinks that a Japanese gecko was introduced to Japan, possibly by trading ships, new technology allowing us to overturn old ideas. To me, that is one of the most satisfying things about science.
And now for the leading edge. Today's The Leading Edge is new wind turbine technologies that could change Japan's future. These new turbines can generate up to 3 times more electricity than conventional ones.
Wind power is one of the world's leading renewable energy sources. For example, in December 2011, an ambitious project was launched to create floating offshore wind farms. This project hopes to use a new type of wind turbine to harness powerful sea winds.
One challenge that wind power faces is cost effectiveness. Isn't that right?
Yes, although you might be surprised at how cost-effective wind power is becoming. Please have a look at this. These are the Japanese government's projections about the cost of electric power generation in the year 2030. According to the projections, wind power will actually be the cheapest way to generate electricity. Right now, around the world, there are many wind power experiments in progress.
Now let's see how one new type of wind turbine invented in Japan is making wind power more efficient.
This man invented a new type of wind turbine. He is Yuji Oya of Kyushu University.
I'd like to hear about your new wind turbine system today.
I could explain it all to you, but it's easier to let you try it for yourself. Let me show you. Right here.
Thank you. So this is it?
This is a regular wind turbine.
This experimental setup consists of a wind-making machine and wind turbine. As the wind turbine spins, a readout shows how much electricity it is generating. Now, Oya pulls out.
Here you go.
What's this?
Don't put it over your head.
No, I won't.
A tub with a bottom cut out of it? Oya says that this can be used to make the turbine spin faster and generate more power. It is supposed to concentrate the wind. But how does it concentrate the wind? Yasu will try to figure it out.
If it's supposed to concentrate the wind, then maybe it should go like this? I have to be careful.
The wide opening faces the wind and channels it toward the small opening, gathering and accelerating the wind. That's Yasu's theory. So how fast will the turbine spin?
Oh, it stopped. I did it wrong.
Uh-oh. Not only did the airflow not speed up, the turbine stopped dead.
Let me try that again. Facing the other way.
Now Yasu flips the tub around and positions it.
Wow! It revved right up. The power reading was 10, and now it doubled.
Double the power? How? To see the effect of the tub on the wind flow, let's watch this wind tunnel experiment. When the larger opening faces upwind, the flow of air piles up in the narrow exit, allowing lots of wind to escape. But when the wider opening is facing downwind, eddies form in the downwind airflow. The eddies are low-pressure zones like typhoons. They have the property of sucking in more air. This raises the wind speed through the turbine by 30%. A side-by-side comparison shows the difference in airflow.
So the eddies are the key?
That's right. The eddies suck in the air.
But in the past, eddies like these were Oya's bitter enemy. He originally studied the effects of wind on structures. This footage is from the collapse of an American bridge. The bridge was shaken to pieces by eddies formed by strong winds.
My career as a researcher was actually a battle against eddies.
13 years ago, Oya began to do research on wind turbines as well. He realized that eddies accelerated wind speed and made turbines turn faster. By adding a lip to the ring, he could generate eddies even more easily. He extracted more and more power from his design, up to triple a regular wind turbine.
It's because you had been battling against strong winds and eddies for so long that you could create this wind turbine.
You could say that.
A wind turbine that concentrates the wind like a lens concentrates light. Oya calls his invention a wind lens.
So, putting a ring around the wind turbine creates eddies that increase airflow.
That's right. And even slightly increasing the speed of the airflow over the blades means a substantial boost in power. And this wind lens wind turbine has other advantages. One advantage is noise reduction. Because the turbine is surrounded by this duct, the sound of the blades cutting through the air is reduced. Also, believe it or not, fewer birds fly into wind lens turbines.
That's so interesting. They must have gone through a lot of trial and error to come up with this design.
At first, they use a long tube with a lip at the end to generate eddies. That increased wind speed 4 or 5 times, but the turbine was too bulky, so they shortened the tube and created a compact ring-shaped duct we see now.
Next, let's look at an offshore wind farm that is making use of these wind lens turbines.
A strange structure looms along the waterfront of Hakata Bay in Fukuoka. It's an offshore wind power platform. The platform is 18 meters across and weighs 140 tons. This giant structure is a prototype that will float out at sea. The platform was designed by Yusaku Kyozuka of Kyushu University, a research collaborator of Oya's. At sea, there is nothing to block the wind, ideal conditions for wind power. In Europe and other places, wind turbines have been built on the seafloor to catch this wind. But these so-called fixed-bottom wind turbines can only be built in shallow waters. Europe is fortunate to have extensive areas of shallow ocean. But in Japan, the seafloor drops off steeply, leaving very little room for this type of turbine. So Kyozuka turned to the idea of a floating turbine. But floating turbines are not yet commercially feasible. So he decided to develop a brand new design for a floating turbine. His idea is a giant floating hexagonal platform.
The hexagon is a shape you often find in nature. It's very common. You find it in the honeycomb of bees' nests, for example. Hexagons are very strong and rigid structures.
This is an experiment on a 1/8 scale model in June 2011. The structure is supported by 6 floats. Waves are generated.
When there's irregular wave motion, it's very clear. You can see how the truss structure is deflected. Yes, it flexes.
The experiment shows the same thing as previous simulations. The hexagonal platform floats stably. But what is the best material to build the platform out of? Kyozuka chose concrete, which is cheap and does not corrode in seawater.
With steel, you have a major problem to deal with. Steel corrodes in seawater. Concrete is very resistant to seawater.
The disadvantage of concrete is that it's heavy, so strong concrete was used to create cylindrical floats with walls just 4 centimeters thick. The inside of the cylinders was then packed with styrofoam to ensure that the floats won't sink even if the concrete develops cracks. With this, the floating offshore wind power platform was finished.
That platform has a lot of clever design ideas. The hexagonal structure, the concrete filled with styrofoam. So how effective is offshore wind power?
The average wind speed over the ocean is 1 to 2 meters per second faster than over land. And that makes a difference. A turbine that receives wind just 1 meter per second faster generates twice as much power over the course of a year.
Japan is surrounded by the ocean. I imagine offshore wind farms in Japan could generate a lot of power.
You're right. The total output of all Japan's current power plant is 280 million kilowatts. If all the offshore wind energy around Japan could be converted to electricity, it would equal 1.9 billion kilowatts. That's 6 times as much electricity. Of course, there are all kinds of practical limitations, but experts said about 1/6 of the total wind energy could be harnessed. In other words, about the same amount of power as Japan currently generates.
Recently, the wind farm platform we saw in the last segment was tested in open waters. Let's see how it went.
The day before the platform goes to sea, the research team is facing a major roadblock. The brake that is supposed to automatically activate when the wind is too strong is not working right.
The most important thing is that the brake works to stop the fan safely when the winds are too strong.
A wind turbine can be destroyed by winds that are too strong. There have been cases of wind turbines destroyed by typhoons and gale winds. It is essential for a wind turbine to be able to brake safely. The research team designed the turbine to brake automatically if its RPMs go too high. The limit set for this turbine is 300 RPM. They work late into the night adjusting the settings so that the brake will kick in if that threshold is exceeded. The day the platform will be launched. Reporters have come from all over Japan to cover this high-profile sea trial. Finally, the time has come to lower the platform into the water.
It should be fine. There are no waves.
The floating platform weighs 140 tons.
It's off the ground. It's up.
Will it float stably in the water? Even Kyozuka, who designed it, looks tense. The platform is settled into the water without a hitch. It floats nice and level. Now it is towed out to the trial site in Hakata Bay, 600 meters from shore. This area gets strong north winds. The site is reached and the turbines are erected. And then the wind lens turbines start turning. They spin vigorously in the sea breeze.
Fantastic. I'm breathing a sigh of relief. The wind really is different out at sea.
2 weeks after the start of the experiment. Is the brake, which was a major concern, working properly? This graph shows 1 day's data. The upper line in red is RPM. The pink line is power generated. The turbine is humming along until a strong north wind blows in. The turbine hits its limit of 300 RPM. Right afterward, the RPMs and power output dropped to 0. The brake worked. After the wind died down, the turbine started up again.
The most important thing is that the turbine stops in dangerous conditions. Now we've confirmed that it does so properly.
The launch was a success. That's good news. So what's the next step for this wind turbine platform?
Have a look at this. It shows how multiple platforms can be linked together to create a large-scale wind farm. This is Oya's next objectives.
How are things progressing?
Right now, Oya is researching ways to reduce the cost of the floating platform. He's also looking into how many wind turbines can be placed on it.
It seems like Oya's platform will be ready to be used in the real world before too long. What do you think, Dr. Mizushima?
Wind has long been used as a source of energy, like the famous windmills in the Netherlands. But these days, scientists are finding new ways to capture wind and to increase the efficiency of generating electricity from wind. Now, we can even harness wind far out in the ocean. Japan's Ministry of the Environment has actually created a manual explaining how to generate power from the ocean wind. Japan is an island nation, so I hope technology like this will one day become used all over Japan. And I look forward to seeing what other new ideas are now on the horizon.
Hi, I'm in Fukui Prefecture. Our Takumi today has come up with an innovative technology to print on various surfaces, like on the frame of these glasses. Let's go meet him. I visited a company that provides specialty printing. Today's Takumi, Koji Muraoka, runs a printing company. Muraoka developed a technology to print on curved surfaces. The design on the cell phone is printed with no distortion, even along the curves. Here we have a smartphone case. And this fishing rod, which is actually plastic. But it simulates exactly the look of bamboo, even the joints. Here's a steering wheel that looks like real wood grain. These patterns and designs don't look like they come from a printer.
Until now, the way it was done was to first print on either film or paper and then transfer it onto the items. But our technology allows printing directly onto items.
I visited the factory to find out how the printing is done. Traveling down this assembly line are cell phones. They're printed inside the machines on the right. But
I'm sorry, there are company secrets involved here, so we can't show you everything.
inside the machine, the pattern or design is first transferred onto a part called a blanket. From there, it is printed directly onto the items. What led to this invention was Muraoka's decision 25 years ago to start a new gift business to rebuild his struggling company. Guests at Japanese weddings receive sake cups. Muraoka had the idea of printing each guest's picture inside the cup. But printing companies said it couldn't be done, so he decided to do it himself.
Because I wasn't in the printing business, I didn't really know how hard it would be. So for 3 years, I worked until 3 or 4 o'clock in the morning.
Muraoka started his quest to print on curved surfaces in a prefab hut. Since printing technology was all new to him, he collected as many printers as he could get his hands on and disassembled them. One day, he noticed a very important thing. When trying to print on a curved surface, the design would always be stretched in the corners. To prevent that, the ink dots needed to be smaller and closer together. It took another 3 years of research for Muraoka to achieve dots 1/5 the usual size. His current technology uses dots 1/10 the usual size. Finally, this special technique for printing on curved surfaces was ready. Because direct printing allows the design to be positioned precisely, even parts that were printed separately align perfectly when assembled. And by printing in layers, he found a way to build up 3D designs on curved surfaces. This technique can give plastic items a luxury touch. His most recent venture is applying direct printing to electronic circuit boards and semiconductors. This sheet of film looks transparent, but under a microscope, you can see a grid pattern printed on it. By printing with a special ink that gives the lines a metal coating, the film can carry electric current.
We're pursuing further development because we believe that other products can be replaced by printed material. This includes products such as radar, absorptive materials, and heat dissipation sheets. It would not only make production of these materials cheaper, it would also make it easier. Printing is going to accomplish big things. This technology is an exciting challenge.
Take a look, a pair of glasses which have a printed pattern made by the Takumi's technology.
Even at the temples where the frames are very thin, the pattern is so well done.
Those are really stylish.
They are, aren't they? And look at the mobile phone cases too.
I like this one. This is so cute.
The printing on the case is so sharp.
And they can even print textures like this.
Wow, how do they do that?
Well, an outline of the design is printed in water-repellent ink, so only the parts that should be textured are printed on. Today's Takumi is looking for even more uses for his printing technology.
Thanks for that report, Michelle. Today on Science View, we cover the latest in wind turbine technology. Any final thoughts, Dr. Mizushima?
The Great East Japan earthquake and the Fukushima Daiichi nuclear disaster have shown the importance of solving the world's energy issues. More and more research is focusing on new types of energy. This includes not only wind, but also geothermal, solar, and tidal energy as well. It's exciting that generating wind power over the ocean can be so efficient. New ideas like this are needed more than ever. It is my hope that Japanese technology can help in creating stable, renewable sources of energy for the world.
I was also impressed by these new wind power technologies. There's so much potential for future development. That's all for Science View. See you next time.